Hello guys, in today's grade 12 physical sciences vertical projectile motion exam clinic, we are looking at the Eastern Cape's physical sciences paper 1 of June 2025. So let's see, this is question 4, right? Vertical projectile motion in this paper was question 4, and it was a total of 20 marks. Okay, it was a total of 20 marks. So we have 20 minutes to finish this question. Okay, we have 20 minutes to finish this question. All right, let's proceed. Okay, let's see. So the velocity time graph below, not drawn to scale by the way, shows the motion of a ball from a certain height above the ground. The ball bounces a few times and all sections of the graph have the same gradient. Ignore the effect of air friction. 4.1. Let's see. 4.1 says give a reason why all sections of the graph have the same gradient. All right? Why they have the same gradient. This is because the ball or the motion, this is because the motion of the ball is in free fall. Okay, the motion of the ball is free fall. Okay, the motion of the ball is free fall, that is to say, constant gravitational acceleration. Okay, constant gravitational. Oops, constant. No, I shouldn't be squeezing this. Constant gravitational acceleration. Okay, that's why. Okay, 4.2 is the downward motion positive or negative? With what we're seeing here, the slope is positive. The slope represents gravitational acceleration, right? So if the slope is positive, representing gravitational acceleration, it means downwards motion is positive. Okay, so our answer is simply positive. That is the assumption of this graph. Okay, cool. 4.3, how many times did the ball bounce? First bounce, second bounce. So the ball bounced twice. 4.4, calculate 4.4.1. Velocity x on the graph. So we have initial velocity and we need this final velocity. We have the duration. So we will say, I'm going to choose downwards positive. Okay, even if you say upwards, it's still okay. You are not restricted or you are not restricted. So downwards is positive. That is my direction, positive direction. So we have initial velocity here, which is 0. We have final velocity that we are finding. We have the time. So we will use this formula. Final velocity equals initial velocity plus a delta t. Okay. Now the final velocity is called x. Initial velocity, as you can see from the graph, is 0. It starts at the origin. We said downwards is positive, so it's going to be positive 9.8, and the time is 2. Therefore, x is 19.6 meters per second. They didn't say magnitude of the velocity, but rather velocity. So you must state direction. It will be 19.6 meters per second downwards, isn't it? Downwards. Proceeding, as we proceed, we're going to 4.4.2. So it says 4.4.2, calculate the time t on the graph. So we can see this time here. There are two ways of doing this. And by the way, there's a mistake here. Okay, there's a mistake here. And this mistake should be fixed like this, let me just show you where the error is. Okay, so this time here is not 5 but rather 4 seconds. Okay, and this is 7.5, this is 8.7, this is 2.2, this is 2, this is 0, and then this one here is x, and this one here is 15. This point here is 11, negative 11.24, and this point here is negative 18. Okay, and this is in velocity, which is meters per second. This is the time in seconds. Okay, so please note the time here is supposed to be 4 and not what? And not 5. Okay, so we will try this. Let's go. So once again, I will choose downwards positive. Okay, I will choose downwards positive. Okay, I will choose downwards positive. We are looking for this time t because it left the ground, reached maximum height and returned to the ground. We can say there is time symmetry here. Okay, remember the graph is not drawn to scale, but the arms are supposed to be honest, the arms are supposed to be the same. So there is time symmetry. I will say, for example, okay, I will say, for example, if there is time symmetry, we will see indeed if there is a need for time symmetry. Okay, but let's see. I will use from maximum height. Okay, from maximum height at 4 seconds to where? To t, right? So I'm looking for that time, all right? I'm looking for that time. So what I'm going to do now, I'm going to do this. I have the final velocity here. I have the initial velocity here. I only need the time. So I'm going to use this formula. Final velocity equals initial velocity plus a delta t. So final velocity will be 15. It's going upward, so it's positive. Initial velocity, which is from maximum height, is 0. We chose downwards as positive, so it means gravitational acceleration is positive. All right. Now, let's see. Now, what do we have? 15 divided by 9.8. All right, 15 divided by 9.8. What do we have? We have, let's see, 15 divided equals 9.8 delta t. So delta t equals 1,53 seconds. Okay, equals 1,53 seconds. Now, having said that, we can therefore say what this means for us is, therefore, t equals that 4 seconds plus that 1,53 seconds. Right. So this correction that I made is because, guys, remember, before we do these things, we confirm where there might be errors. I will show you why it was supposed to be an error. If this time from here to here was going to be 1,53, I want you to imagine this. If it was 5, right, you will have to add 1,53 to 5. But let me show you something now. Okay, so I'm going to try. I don't have to go to the next page. Let me try it here. Let me scroll down. Let me try method 2. Okay, let me try method 2. Method 2 will be from leaving ground to returning. All right, from leaving ground to returning. All right, from leaving ground to returning. All right, so what are we saying? We are saying final velocity equals initial velocity plus a delta t. right? Final velocity, this is when the ball reaches the ground, right? Which is downwards motion. It's going to be positive 15. When it leaves the ground at negative 18, right? Acceleration, because we're saying downwards is positive, it's going to be, let me just highlight, downwards positive. Then acceleration will be positive 9.8 delta t. 15 plus 18 is 33, isn't it? So 33 equals 9.8 delta t. 33 divided by 9.8. Okay, 33 divided by 9.8, what do we get? 33 divided by 9.8, we get, what are we getting? Delta t will be 3.37 seconds. Do you see this? So the duration here is 3.37 seconds. This, therefore, we can say, check this out. T will be, the time here is 2.2, and the duration here is 3.37 seconds. Right? Now, what is the total? 2.2, come on, it's 5.5 seconds. Do you see this? It's 5.5 seconds. So indeed, this was supposed to be 4. Do you guys see this? Our answer here, let's now fix it. Our answer here will be 5.53 seconds. Note this difference is also permitted. I want to go with this one because with this mistake, you're gonna get 6.53, and that is not your mistake, it's the examiner's mistake. Okay, cool. So I'm going with this answer here. All right, let's go now. 4.4.3, they say determine the height above the ground where the ball was projected. Height above the ground where the ball was projected. So what we know, for example, we know the initial velocity was 0. The final velocity was, we calculated it. It was 19.6 meters per second downwards, right? We are only looking for the height. So we can use this equation. Once again, let's choose downwards is positive. Okay? So we'll choose downwards is positive. Remember what I said. For the first 2 seconds, okay? For the first 2 seconds, initial velocity is 0. Final velocity is equal to x, which we found to be 19.6 meters per second downwards. All right? Now, let's go. We are looking for delta y. Let's go now. You can use this formula. Vf squared equals Vi squared plus 2a delta y. The reason I'm using this one and not using the one of delta y equals Vi delta t plus half a delta t squared is because a lot of us, we don't like quadratics when we're in physics, right? All right, let's see now. So the final velocity was 19.6, isn't it? It was 19.6 square. Initial velocity was 0 square. Acceleration is 9.8 and delta y is unknown. We know 19.6. We know 19.6 squared. Oh, in fact, we don't know. 19.6 squared is 384.16, and 2 times 9.8 is 19.6 delta y. Now, 284.16 divided by 19.6 will give us delta y being 19.6 meters, right? So this is the height above the ground where the object was projected. Therefore, height is 19.6 meters. We are good, right? Perfect. Now let's go. 4.4.4. 4.4.4. They say we must determine the maximum height reached after the first bounce. Maximum height reached after the first bounce. Let's see what we have. We have the initial velocity, which is let me just write it as negative 18 meters per second. And then we have, or if you like, this is basically 18 meters per second upwards, right? And then what else do we have? We have the final velocity, which is 15 meters per second. What do we say? Downwards, all right? Downwards. This is the information we have, right? And then while you are on it, you should also ask yourself this question. Okay, you should also, oh, sorry, the second bounce. I'm sorry, the second bounce, not the first bounce. Okay, the second bounce, not the first bounce. Sorry. So for the second bounce, it is this one here. Its final velocity is 0, and then its initial velocity is negative, or let me just write it as 11.24 meters per second. Since it's downwards, so it'll be up. Do you see this? It's upwards. And then what else do you want to know about the time here? So the time here is 8.7, right? The time here is 8.7 minus 7.5. This looks like 1.2, isn't it? If you don't like that, you can also note, right? You can also note that you are looking for delta y. Whichever equation will be convenient for you, use it. Once again, I will choose downwards being positive. Okay, downwards being positive. So all the equations you can use that involve delta y will give you the correct answer. So I will choose this one here. Vf squared equals Vi squared plus 2a delta y. What is who's this guy? What is final velocity? Final velocity is 0. What is initial velocity? It's minus 1.24 close square. And then acceleration is positive 9.8. Delta y is unknown, right? All right, so 0 equals 126.3376 plus 19.6 delta y. So if you like, let me just proceed. You can say this is negative 19.6 delta y equals 126.3376. Let's see. So 126.3376 divided by 19.6. What do we get? Okay, we are getting delta y equals negative 6.45. All right, we are getting negative 6.45. So the maximum height, therefore, it is not surprising that it's a negative value. We can say this delta y is 6.45 meters where? Let's say above the ground, right? Above the ground. Okay, above the ground, because negative means upwards. So above the ground is upwards, right? So we're good. Perfect. Now 4.5 with ease. 4.5, sketch a position time graph for the entire motion of the ball. Indicate the following on the graph. Let's see. This is the position versus time. I'm going to draw it like this. This is y in terms of meters, and this is time in terms of seconds. We must show, let's see, we must show height above the ground where the ball was projected. It was projected from 19.6. Let's go. It was projected from 19.6. Here is it. And then that motion lasted 2 seconds. And then maximum height reached after the second bounce. So, okay, it's fine. The first bounce, here is it. And the second bounce, it reached maximum height. I don't like this one. Okay. And then this, much better. So this was 2.2. This was 5.57, right? 5.57. This was 7.5. And this, finally, it's 8.7. Okay. Finally, it's 8.7. Your graph looks something like this. Okay. Your graph looks something like this. Okay. So they say you must show all the times indicated on the graph. There was an error here. It's not supposed to be 5, it's supposed to be 4. So all the times are shown. Maximum height reached after the second bounce. That maximum height was, I still don't like it. So that maximum height was 6.45. You guys remember? 6.45. All right? And what else? Height above the ground where the ball was projected. Okay, this is it. That's sufficient. Right? So that's sufficient. We are fine. And this is how you attempt these questions. I hope you know why we took long in this question. Right. So this is it, guys, and bye bye.